This is my first of over 20 videos on casting shadows, and the rest of the videos are at my YouTube channel called Casting Shadows 07W, and it goes over everything in my new book, Ellen's Guide to Casting Shadows, on Amazon, where the Kindle is only $5. Here's an object on a reflecting surface like water. The incident light ray from the object goes down to the reflecting surface and then bounces back as the reflecting ray, so that angle 1 is the same as angle 2. The eye follows this reflecting ray down, so it thinks that the object is below the water here and is an upside-down version of the actual object. Here we see the reflection of a tree that's close to the lake and also next to a reflection of a mountain that's far away. So how do we know where to place the reflections? Well, the only way to do it is to look at the side view. And so here's the eye, and here's the tree on the other side of the lake. And the top of the tree reflects closer to the eye than does the bottom of the tree. And as a result, we see an upside-down tree. Now, what about this distant tree? Where does that go? Well, you just follow it down till it reflects to the eye, and you'll see that it's above the nearby tree. So this would be what the eye would see. Shadows are caused by the lack of direct light. In other words, these buildings block the light from getting to these shaded areas. In contrast, reflections are from bouncing light. So the light will come hit the bird, then it will go down to the water, and then it will go to our eye. The shadows are opposite the light source, so it varies with the position of that source. And here, the side of the glasses cause these shadows that radiate out because the sun is in the middle up here somewhere. Reflections, on the other hand, are always underneath the object like these yellow flames. So they vary with the position of the viewer. Shadows are best seen on matte or opaque surfaces, and we should see underneath the shadow. Here's a tile floor in the shade. When I photoshopped away the tile, it looks less like a shadow. Reflections are on shiny surfaces that are either opaque or translucent, and we generally can't see under the reflection. Here is a reflection in water, for example, and we can't see underneath the water. Shadows are dark, especially near the casting objects. So the shadow of this spike is darkest near the wheel, and then it gets lighter as it moves away. I made the shadows in the second case a uniform value, and they don't look nearly as convincing as these shadows here. The fact that it's darker in the back and lighter in the front makes this surface look more horizontal than this surface. You could also have the gradation being dark in front and light in back. In either case, gradations make a surface look horizontal. Now for reflections, they mirror the values of the object, like these pine cones are dark and the reflections are dark. And it also mirrors the colors of the object. So here we have red on this glass and red in the reflection. Shadows take on the complementary color to the light. And since light is generally yellow or orange, shadows have tinges of blue and violet. Particularly outside, they'll have a large amount of blue. And that's from the diffuse blue sky, which is a huge light source that affects everything. But we don't see it in the blue tinges in the lit area because the sun is so much more powerful than this blue skylight that it eliminates any blue tinge. So we generally only see it in the shadows and the shaded areas. In contrast, reflections show the colors of the object, like green grass, as well as the light, like the yellow sun and the orange sky. So how do the shapes and sizes of shadows and reflections differ? Shadows vary with the direction of the light, with perspective, and with the position of the viewer. Reflections, on the other hand, are upside-down versions of the subject. They're as long as the subject, and they always lie directly underneath the subject. Let's evaluate this picture. So in this first diagram, I connected the hands of the people to the shadows of those hands. And in that way, I am able to find the light direction. And all these light rays converge toward the sun, which is the vanishing point. Now, if I just follow the shadows, the line of the shadows, I'll come to the shadow vanishing point, which is always on the horizon at eye level and always vertically underneath the sun. Shadows help us understand the picture. So in my drawing here, this middle guy is touching the ground because he's touching his shadow. This one is in the air because he's not touching his shadow. We probably wouldn't really appreciate that difference if it weren't for the shadows. And this shadow, well, he has a mind of his own. There are a few situations when we see both shadows and reflections. One case is a swimming pool, where the shadow is on the bottom of the pool, and we see bits of pink reflections or yellow reflections on the surface of the water. Another situation is wet sand, and here you see the shadow of the bird that has a bluish tinge, and the reflection that has more of a yellow tinge from the sun. And we could see that the sun must be going in this direction because the shadow is to the left of the bird. And again, the reflection is directly underneath the bird. Shadows on water are best seen from a high viewpoint. The sun is going in this direction, causing this water to be green because it combines with the blue sky. The shadows are a dull blue-gray because they don't receive any yellow from the sun. When we go down to the shore, we can see that the line between light and dark is very vague. This must be Photoshopped because we would never see such a sharp shadow on water, especially at this low viewpoint where the line should be vague like it is here. We also see both shadows and reflections when there's silt on the water, and here, for example, is a blue-gray shadow, and underneath is the reflection. And you can see that the white area is not as white in the reflection, and the dark area is not as dark in the reflection, and as a result, the value contrasts of the reflection is much less than we see on the bird. With translucent objects, the light goes through the center of the glass and causes this flame-like appearance, whereas shadows of the side of the glass vary with the direction of the sun. Both shadows and reflections are seen on semi-glossy surfaces, but shadows are best seen on matte surfaces that aren't shiny, and reflections are best seen on very shiny surfaces. So they're both attenuated on semi-glossy surfaces. That means we really don't see the shadows and the reflections well. Here is a shadow because it creates a diagonal, and we can see a vague reflection of this person as well as a reflection of the light source. These are reflections because they're directly underneath the birds and they have a uniform value, whereas shadows would be darkest near the birds. In this case, the objects are on glass, so we see reflections of the object on the glass, but the glass lets most light pass through so that the shadows are now actually on the back wall. We see reflections of these vertical window panes, but not of the horizontal panes, and that's because the reflections go in this direction. We also see reflections better in less turbulent water than in water where there's more turbulence. Let's compare the reflection of this bowl on a light surface versus a dark surface. And you can see that in this second one, we see the reflection most clearly. And that's because the dark surface absorbs any ambient light. So it lets us see the reflection from this bowl. In this first case, the light surface will reflect light to us, so it obscures any light that will be reflected from this bowl. This is a summary of the characteristics of shadows versus reflections. My next video will be about the basics of shadow casting. Check out my other YouTube channel for the rest of these videos. It's called Casting Shadows-07W.